Okay, the notes that you are going to complete for your virtual day today is about rationalizing denominators. Okay, and what that means is sometimes when we have to divide by a radical, we don't want that radical in the denominator. Okay, so rationalizing the denominator is going to change how something looks, but it's not going to actually change the value of it. Okay, so why this is important: if we have a whole number that is the hypotenuse of a 45, 40, 90 triangle. Okay, so for instance, if we knew that this side was 18, or if it's the long leg in a 30, 60, 90 triangle, okay, and remember the long leg is opposite that 60-degree angle, we have to divide by those respective radicals to figure out what the length of the legs are. Okay, so in a 45, 40, 90, since this hypotenuse is supposed to be something times the square root of 2, we're going to divide by the square root of 2. Okay, now again, dividing by a radical, we do not want to have that radical in the denominator. Okay, so right now, that the length of both of those legs in this 45, 45, 90 triangle is 18 over the square root of 2. To rationalize that, or to get that denominator, or that radical out of the denominator, we're going to multiply by the square root of 2 over the square root of 2. Okay, what that does, anything over itself technically is equal to 1. Okay, so like I said before, we're not changing the value of this, of the length of this, of the legs of this 45, 45, 90 triangle. We're just going to change how it looks because we don't want that radical in the denominator. Okay. Now, in the numerator, when we multiply straight across, we just have 18 square roots of 2. Okay. In the denominator, when we take the square root of 2 times the square root of 2, we get the square root of 4, which is just 2. Okay. The last thing that you need to check is, does that number that's in front of the radical in my numerator over the denominator now, does that simplify? Okay, so if we look at 18 over 2, 18 over 2 is 9. And so our final answer for the length of both of those legs of my 45, 45, 90 is 9 square roots of 2. Okay. So I can even write that on my picture now. Okay. Now for a 30, 60, 90, okay, if that long leg is a whole number, we're going to divide it by the square root of 3 because it's supposed to be something times the square root of 3. Okay, so when we consider 18 over the square root of 3, that is technically the length of that short leg. Okay, but again, we don't want the radical in the denominator. Okay, so just like we did over here when we multiplied by the square root of 2 over the square root of 2, we're going to multiply this by the square root of 3 over the square root of 3. Okay. Now, numerator again, we just multiply straight across. So we have 18 times the square root of 3. In the denominator here, when we take the square root of 3 times the square root of 3, 3 times 3 is 9. So what is the square root of 9? That's 3. Okay. Again, that last step, look at the number in front of the radical and what's in your denominator. 18 over 3, does that simplify? It sure does, to 6. And so the final answer for this would be 6 square roots of 3. Okay. Now for the 30, 60, 90, that only represents the short leg. Okay. In class tomorrow, we will talk about how to get the length of that hypotenuse. Okay, so some examples here. 1, 2, 5, and 6 are all, it's like we're finding the length of the leg of the 45, 45, 90. Okay. 3, 4, 7, and 8. That's like we have the long leg and we're trying to find the short leg of our 30, 60, 90. Okay, so splitting those down the middle to kind of keep it straight in your mind, what we're going to be dividing by. Okay, so let's start with the a square roots of 2. Okay. Oh, try this again. Okay. To find the length of that leg, or either leg, in the 45, 45, 90, we need to divide by the square root of 2. Okay. And in doing that, gee dang it. What nation? Okay, so when we divide by the square root of 2, to get that radical out of the denominator, we need to multiply by 1 just a little bit. It looks a little bit different, okay? Remember the numerator, we just multiply straight across. Denominator, when we take the square root of 2 times the square root of 2, we just get 2. The last thing we need to check, does 20 over 2 simplify? It sure does. So the length of that short leg, or I guess the length of the leg, both of them, the legs, would be 10 square roots of 2. Okay. In number 2, again, we're going to start by dividing by the square root of 2. Okay. To get the radical out of the denominator, we multiply by the square root of 2 over the square root of 2. In the numerator, we just multiply straight across, so we throw those two things together. Okay, in the denominator, we have 2. Okay, the last thing you need to check, 15 over 2. Does that simplify to a whole number? This one does not, and so our final answer is actually going to just be that fraction with the radical in the numerator instead of the denominator. Okay, so if it simplifies to a whole number, write it as such, but if it does not simplify, it'll look like this. Okay. Number 5, we are going to be multiplying 9 over the square root of 2 by the square root of 2 over itself. Okay. numerator, we have 9 times the square root of 2. In the denominator, we just get 2. Again, I'm going to ask myself, that number in front of the radical, does 9 divide by 2 evenly? The answer is no, so the length of both legs of my 45, 45, 90 triangle, whoa, not the square root of 5, don't know where that came from, is going to be 9 square roots of 2 over 2. Okay, last example here with the square root of 2. When we divide 8 by the square root of 2, we're still going to multiply by the square root of 2 over itself. My numerator doesn't change much, but my denominator, I'm just left with 2. And the last question I ask myself, does 8 divide by 2 evenly? Yes, yes it does. Since 8 divided by 2 is 4, 4 is what will be in front of the square root of 2 in my final answer. Okay, so for these examples, one way to kind of check your work, I guess, is if that hypotenuse is even, your answer will be just a number times the square root of 2. If your hypotenuse is odd, like in number 2 and 5, your answer will have a fraction. Okay. All right. Moving on to the 30, 60, 90 examples here. Okay. In any 30, 60, 90 example, we will be dividing by the square root of 3. Okay. So when we divide 21 by the square root of 3, to get that radical out of the denominator, we want to multiply by the square root of 3 over itself. Okay. In my numerator, I have 21 times the square root of 3. Okay, remember in the denominator, when we take the square root of 3 times the square root of 3, we're left with just 3. The last thing you need to check, is 21 divisible by 3? If it is, we're going to simplify, and this one it is. So our final answer for the short leg of the 30, 60, 90 would be 7 square roots of 3. Okay. Now, that last question we ask ourselves, sometimes they're not always going to simplify. Okay. So here, when I divide 16 by the square root of 3, I'm still going to multiply by the square root of 3 over itself. Okay, in my numerator, I have 16 square roots of 3. In my denominator, I'm left with just 3. So like this one, 16 is not divisible by 3. And so your final answer, much like what we did on numbers 2 and 5, our final answer is going to look a little scary. Okay, but it's still a valid, that is the length, that's the exact length of the short leg of 30, 60, 90 triangle. Okay, 7, we're going to take 10 divided by the square root of 3. Still multiply by 1, just looks a little different. Okay, in my numerator, I have 10 square roots of 3. In my denominator, I have 3. Okay, is 10 divisible by 3? 10 is not divisible by 3. Okay, so since that is not divisible by 3, our final answer will be 10 square roots of 3 over 3. And again, that represents the short leg. All right. Last example here, dividing 12 by the square root of 3. Okay, we still, not 10. We still want to multiply by the square root of 3 over the square root of 3 to get rid of that radical in the denominator. Okay, numerator will be 12 square roots of 3. Denominator is 3. Okay, ask, is 12 divisible by 3? It sure is. Okay, so since 12 divided by 3 is 4, our final answer for the short leg is 4 square roots of 3. And we will put this into practice tomorrow.